Hey guy, look at this. It's a simple gold ring. Or, is it? We see gold everywhere. In jewelry, in our electronics, even in our teeth. We desire it. We mine for it. We fight over it. It has driven explorers across oceans and fueled the rise and fall of empires. It's just an element. Number 79 on the periodic table. A heavy, yellow metal. So why has this particular substance captivated humanity for millennia? What makes it so special that we've pulled nearly all of it, ever mined, into a single, ever-growing pile? The story of gold isn't just about chemistry or economics. It's about us. It's about our perception of value, our quest for permanence, and our fascination with the cosmos. The atoms in this very ring began not in a mine, but in the cataclysmic collision of dead stars, billions of years ago. This metal isn't just from the Earth, it's from the heavens, and the amount of it in the entire world. Well, that might be the most surprising thing of all. So, what if I told you that all the gold ever mined could fit inside a single Olympic swimming pool? Or that it can be stretched into a wire so thin it could wrap around the world hundreds of times? Today, we're going to dig deep into the glittering world of gold, uncovering 10 facts that will change the way you see this timeless metal. We're going to explore its incredible physical properties, its cosmic origins, and its surprising role in our modern world. And as always, thanks for watching. Chapter 1. Let's start with the basics. Au, from Latin aurum, meaning shining dawn. It sits at atomic number 79. Every atom of pure gold has exactly 79 protons. That number is the very definition of gold. 78 protons would be platinum, 80 protons would be mercury. First, malleability. Gold is the most malleable metal. You can hammer it into incredibly thin sheets. 1 gram, about a paperclip, can cover a square meter. Those sheets are called gold leaf. Gold leaf can be only a few atoms thick. They become translucent. Light can pass through, often greenish blue. Artisans use this to gild domes and statues with tiny amounts of metal. Next, ductility. Gold can be stretched into wire. 1 gram can become a wire over 2 kilometers long, more than a mile. That's why it's used for microscopic bonding wires in electronics. Gold is also an excellent electrical conductor. Silver conducts slightly better, but it tarnishes. Copper conducts slightly better, but it corrodes. Gold resists corrosion and oxidation. A gold-plated contact stays clean and conductive for years. That's why high-end audio and critical computer parts use gold plating. Gold is a noble metal, chemically inert. It doesn't rust, it doesn't tarnish, it doesn't corrode. Incredibly soft and easy to shape, yet one of the heaviest metals. Density 19.3 G Sensi number 3. Almost twice as dense as lead. It conducts reliably, resists decay, and has a warm, unique luster. This perfect storm of properties in element 79. It's not just a metal, it's a masterpiece of physics. Chapter 2. So, where does all this amazing stuff come from? The elements we're all made of, like carbon, oxygen, were forged in the hearts of ordinary stars through nuclear fusion. But stars, even the most massive ones, can't create elements as heavy as gold. The leading theory: most of the universe's gold formed during collisions of neutron stars, the kilonova. In that brief, violent moment, the right temperature, pressure, and neutron flux exist to forge the heaviest elements: gold, platinum, uranium. Billions of years ago, these collisions seeded the dust and gas that formed our solar system. Gold atoms rained down on the primordial Earth. Because gold is so dense, most sank deep into the planet's core. Scientists estimate enough gold in the core to cover Earth in a 4-meter layer, but it's inaccessible. The gold we mine is the tiny fraction left in the crust, brought upward by hydrothermal fluids. As water cools and pressure drops, dissolved minerals precipitate into quartz veins with embedded gold, lode deposits. Over time, erosion frees heavy, inert gold. Rivers carry flakes and nuggets. They settle on inside bends and behind boulders. Alluvial or placer gold. The gold in your ring, born in a cosmic collision, mixed into our planet, sunk to the core, brought up by hydrothermal water, weathered out, washed down a river, waiting for millennia to be found. Finding gold, even after concentration by geology, is incredibly difficult. Gold is rare, extremely rare. The average concentration in Earth's crust is about 4 parts per billion. You'd process a chunk the size of a large family car to find a grain of sand's worth of gold. This scarcity is why operations are so vast, from mile-wide pits to tunnels kilometers deep. Ore grade. A high-grade mine might have 8 to 10 grams per ton. Low grade, often 1 to 2 grams. Think about that. To get a small coin's weight, you excavate, crush, and process a literal ton of rock. A dilute cyanide solution dissolves gold, which is recovered and smelted. Molten gold sinks, impurities skim as slag. Result: a doré bar sent to refiners for high purity. How much gold have we accumulated? The World Gold Council estimates around 205,000 tons. Melt every ring, coin, and bar into 1 cube, about 22 meters per side, fitting inside an Olympic pool. All the gold in history, in a block you could circle in under a minute. Nearly every ounce ever mined still exists. With only about 1.5%, 1.7% added annually, supply grows slowly and predictably. You're buying into a finite historical stockpile built over 6,000 years, the atoms unchanged. A finite resource on a planet of infinite desire, the engine of much of human history. With new gold difficult and expensive to mine, the world's cities are massive deposits. The urban mine, recycling supplies roughly 25 to 30% annually and responds quickly to price. Old, broken, unfashionable jewelry is the single largest source of recycled gold. It's recast into new jewelry, turned into investment bars, or used in industry. Your old smartphone, laptop, and desktop all contain gold in connectors, switches, and bonding wires. A typical smartphone might contain about 30 milligrams of gold. 1 ton of old phones can yield up to 300 to 350 grams, versus 1,2 GT in low-grade ore. Specialized facilities recover gold alongside silver, palladium, and copper. Recycling uses a fraction of the energy and avoids major land and water impacts. About 7 to 8% of demand is industrial and technological. The invisible gold that makes devices work. Gold plates contacts and forms fine bond wires where reliability is non-negotiable. In dentistry, gold alloys endure, inert, hypoallergenic, perfectly shapeable. In space, microscopically thin gold reflects heat, protecting equipment and astronauts. At the nanoscale, gold particles power diagnostics and experimental targeted therapies. Soft enough for art, durable enough for millennia, and vital to advanced tech. Ancient meets futuristic. Beyond jewelry and industry, gold is a primary investment asset, a store of value. Investors buy bars and bullion coins, or use ETFs backed by vaulted bars. Central banks hold over 35,000 tons, about 17% of all gold ever mined. The US is the largest single holder. Others include Germany, Italy, France, Russia, and China. They hold gold as a universal, non-sovereign asset, a hedge against currency volatility, inflation, and crisis. Gold trades around the clock. What drives its price? Supply, demand, sentiment, and trust. The US dollar's value is key, typically an inverse relationship. Inflation and real interest rates matter. Low or negative real yields lower the opportunity cost of holding gold. Geopolitical or financial turmoil. Investors flock to gold as insurance. Over centuries, an ounce of gold has held purchasing power, then a fine toga, now a fine suit. Daily moves reflect a global conversation about risk, value, and trust, a barometer of financial health. We've explored the wonder, the utility, the value of gold, but the story of gold is not all glitter. Extracting this precious metal can carry significant environmental costs: water use, land disruption, chemical hazards. Cyanide and mercury used in extraction pose serious risks. Spills can contaminate soil and water for decades. They can poison fish, wildlife, and harm local communities. Social impacts include poor labor conditions, child labor, and human rights abuses, especially in small-scale and artisanal mining. A movement toward responsible sourcing is growing, tracing gold from mine to product to meet standards. Industry bodies like the LBMA require refiners to avoid links to conflict, abuses, and illegal activity. Brands offer recycled and certified gold. Programs support fair pay, safer work, and environmental protection. The true cost isn't just market price, it includes environmental and social well-being. As awareness grows, the industry is changing. The future may hinge on sourcing that respects planet and people. The allure of gold is timeless, but our methods must evolve. Outro. So, we come back to this simple ring. It's no longer just a piece of metal, it's a collection of atoms forged in the collision of stars. It's a tiny piece of a finite global treasure that could fit inside a swimming pool. It's a material so versatile it can be used to gild a cathedral. It can be used to protect an astronaut. It can be used to connect a microchip. It can be used to symbolize eternal love. Its journey is our journey: cosmic violence, geological patience, human ingenuity, enduring desire. The story of gold is a mirror. It reflects our greatest achievements in technology and in art, and the costs of our consumption. From alchemists who dreamed of making it to physicists who explain its color, gold pushes our knowledge and ambition. What we see in gold is a desire for something real, something permanent, in a changing world. It connects our past to our future, from pharaohs to particles that may help cure disease. And as always, thanks for watching.